Good. So, ladies and gentlemen, a warm welcome to Lausanne this morning. Great to have you here. Great to have you at our event for space technology in Switzerland. I also want to welcome our viewers that are joining us online. Great to have you. Welcome to Lausanne on a virtual basis. So we're going to have, this is our first space event that we organize from Advantage Austria, Switzerland. It's a great pleasure to cover this topic. It's a great pleasure to be in Romandie, one of the hotspots for space in Switzerland. And it's our aim to gain an overview of what's going on here in the market. I think here in the region, is, as I said, it's one of the hotspots, especially for space hardware. With these two coming days, we're going to meet a lot of people, a lot of companies, do a lot of networking, so we will know a lot of good things that are going on here in Switzerland. To start out with, we're going to live stream two presentations. Gregory Bourbon, you're going to be talking about Swiss activities in space industry, and Emmanuel David, you will be talking about the sustainability in orbit. That's all from my side. I'm happy that you all are with us, and I would like to hand over the word to you, Grégoire, please.
Thank you. Okay, thank you very much. Good morning from my side, especially good morning for the ones who are in live stream now. Well, I hope you will enjoy also, but of course being here is better, especially with the good weather that we have and the good connections that we will have over the two next days. So I'm Grégoire Bourbon, Head of Space Exchange Switzerland, and in the next 15 to 20 minutes I will give you an idea of what we are doing in general in Switzerland with some examples. And of course, if you have any questions or if you want to reach out, of course, also after these 2 days, do not hesitate to come to me and to the team of Space Exchange Switzerland. But basically, let's start. I don't know if it's working like this. No. Oh, yeah. Let's start with a short movie about which will give you an idea of what we did in the past, from the past to the present and the future, about specifically what we have developed in Switzerland. And I will come back later on some examples there to explain you why it was important and how it came like this. So let's go in this short movie. Okay, so that's in 2 minutes and something, what we did and what we are currently doing in Switzerland. So along my presentation, you will see a lot of things where you say, okay, that's the same in Austria. So indeed, we are sharing a lot of things together, and you will see there are a lot of examples that can apply to all of us as a country. First of all, a few words about Space Exchange Switzerland. We are a national platform financed by the Swiss Space Office. So in Switzerland, we don't have a space agency. Our agency is the European Space Agency. We have an office in Bern in the federal administration, so at the State Secretariat for Education, Research and Innovation. And they are basically managing the different programs where we are in Switzerland investing at the European Space Agency. And we have a small part of the money, of the public money used, which is staying in Switzerland, and one of these parts is for Space Exchange Switzerland. So we are promoting not only at industrial level relationship. We are hosting, of course, companies from abroad, but we are also going abroad to explain what we are doing in Switzerland. But we are also promoting space in the public in general, and also to the students, for example, where it is a very important, it's the talents of tomorrow. So we are supporting students enrolled in Swiss universities to consider career in the space domain, and we have grants for them if they go abroad for internship. So if in your company you're looking for talents, and today, especially at EPFL, but as you know, we have many other universities, if you think that you want to get closer to one of these universities, also with students, we are there to support them to go in your industry or in your university, of course. So we are implemented by 5 universities. We have the leading house here at EPFL, and then we have in our team people at ETH Zurich, the University of Zurich, and then the University of Lugano in the south part of Switzerland, Italian part, and at the University of Applied Science in Bruck-Windisch. So we are clearly, and we spoke before about the Röstigraben, so we are clearly bridging this Röstigraben with this Space Exchange Switzerland. We are a founding member of the European Space Agency. At the beginning, in '75, we were one of the 10 countries, and that's why in May this year, we hosted the 50th anniversary of ESA here in Lausanne, one of the 4 official events of ESA in Europe. So it was just at the Swiss Tech Convention Center, and that's why you can grab it if you don't have it already, and sorry for the ones online. But we had a small gift, a goodie for the 1,200 participants from the public who came to see the different activities ESA done in the past and will do in the future. So there is a small light. The idea was to illuminate the Europe skies. So that was one of the gifts that you can have also today. But before ESA, we were already part of Apollo mission. So you have seen the example of the Omega Speedmaster, and we are known for a watch, and Omega Speedmaster was worn by the astronaut, Apollo astronaut. But before that, even there was this experiment coming from the University of Bern. It was one of the only, I think the only one out of US that was in the Apollo mission, and it was put on the moon. On the moon, it was a solar wind experiment. So the idea was to collect solar wind particles, and it was on 4 out of the 6 Apollo missions that were landing on the moon. And well, for the small story, in fact, as the experiment should have exposed as much as possible, this one was planted before the American flag. So that was one of the, Buzz Aldrin was saying my Swiss flag. So very important also at the time that we were involved in this. And it started basically what was done at the University of Bern and still continue with the space activities for science. I wrote here for the benefit of citizens. In fact, it's coming from our Swiss space policy. It was revised in 2023, and one of the first important points is that we do space activities and we invest in space activities from the public sector for the benefit of citizens. Not only because it's fun, of course it's fun, I'm an engineer, I like space activities, but it's because we have application, we can have access to all these missions, we can access the data, so it's important to be part of this, and I'm sure you're sharing this in Austria. Well, education, research and innovation, that's in our DNA. We are at the middle of Europe. again, something that we are sharing together. And that means also we need to do international partnerships. That's very clear. We are too small to work alone, and especially in the space business, we need to be with others. That's why we decided at the time to be part of the European Space Agency. That's why we are part of CERN, for example, and other important institutions. So we know also how to bring excellence in science to key innovation, contributing to world major discoveries. And I will also give examples there. But let's start with education. You will have some examples today of these, what we call the students' initiatives or students' associations. So we have a lot of them here, and Emmanuel is better than me to tell you exactly what is happening, and you will meet with the students there. But in general, so between EPFN and also ETH Zurich, there are more than 500, and the number is always growing. Yeah, you have a question? No? Sorry. The number is growing, so we have more than 500 students at university level who are involved in one of the 10 associations around space activities, rocket, rovers, CubeSat, even analog astronauts in the Alps, for example. So for us, it's really important, especially in our mandate from the Confederation, to consider them, because in 1 or 2 years, they will be there to build startups, to work in industry, to be the future talents in our ecosystem. And that's why also when we are organizing a professional event, we always give the floor at some point to one of these student associations, one or more of these student associations. So very important for us. From education to research. So you probably know about that. Well, 30 years ago, exactly, it was the 6th of October, there was the first exoplanet discovered by two people from University of Geneva, Michel Mayor and Didier Queloz. They got the Nobel Prize in physics in 2019 for this discovery. And more interesting also to show this link between research and industry. When ESA selected the first small mission in 2011, they decided to select the characterizing exoplanet satellite, CHEOPS. And this was proposed by the University of Bern with Geneva and with a lot of Swiss consortium around. And then, of course, it became an ESA mission, so there was contributions from other countries. And this satellite was launched in 2019, the same year where they got the Nobel Prize. So very important here to show this from basic science, basic research to implementation, and of course there are a lot of data coming from the satellite characterizing these exoplanets. Exploration, well, I give two examples here of ExoMars. So we were speaking about the University of Bern. They also led an instrument on the ExoMars TGO with turning around Mars with the Cassis instrument. You see here one of the pictures taken by this instrument, and there are a lot of these pictures, of course. And we are now, and tomorrow you will visit the Space Exploration Institute in Neuchâtel. So Jean-Luc Josset is a PI for ExoMars, the CLUPI instrument. So a camera on board the ExoMars rover. Who should fly on 28. We expect that it will fly in 28 to be on Mars very soon after. We expect that. And so that's also important for us to demonstrate this interaction between the ecosystem, again, from science to industry to students also involved. There are a lot of PhD students already now at the University of Basel to work on the future data that we will get from Mars, from the instrument, and to support the discovery that we will do after. Well, you saw from the movie, we're a reliable and strong heritage in the space domain. I give here again some examples. There are many more, of course, but I wanted to give let's say the major examples that we had, especially at the beginning of ESA, and that remains nowadays. So with the atomic clocks, of course, well, Switzerland is known for a watch industry. It was not a big surprise when it was decided to build on these competencies and provide the Galileo satellites with atomic clock. So the core of these atomic clocks are basically coming from a company. It was called SpectraTime at the time. Now it's Safran in Neuchâtel. and they are providing the cesium and the rubidium atomic clocks on board the Galileo satellites. APCO technology, not far away from here in Aigle, key actor, of course, here providing mechanical parts, structures, but also on-site in Kourou, where they are basically supporting the integration of launchers. And beyond gravity, that's again something that we are sharing together. So beyond gravity, among all the activities they have in all Europe and the US, well, basically they are providing since the beginning of Ariane the payload fairing of the rocket. So basically they're on top of each European rocket, and these payload fairings are basically built in Switzerland, in Amen, before going to Kourou in French Guiana. But now we are also moving to be a leader in the new space economy. And here you have examples, especially coming from the area, that you will also see and visit today with Swiss 212. Well, I don't want to spoil the presentation. It will be better, of course, from the people at Swiss 212. But they are really now in this revolution of telecommunication satellite from geostationary orbit. So very important. Clear space. Here supporting the first ESA mission to remove space debris that you will also visit tomorrow. And Pictera, it's one of the important examples that we have in the area about development of an AI platform powering geospatial insights. Very important again, because again, we are speaking about benefit for citizens. So of course, all what is about using data, applications, that's something important, and Pictera is in it. And DeFi space, I put this example, again, I could put any other ones, but DeFi space very important because the founder came from one of these students associations at EPFL. He was president of the spacecraft team, and they managed in 6 months at the time to fly one of their software development in one of the transporter mission with SpaceX as a students. And then they decided to say, okay, maybe there is something we can do there. And they decided to incorporate DeFi space more than 1 year ago now. And in March this year, they were on board Transporter 13 with their small sats, a small part on the platform, Cluster Gate. And very interesting from our point of view. Well, short time between the incorporation of the company and the first flight. But also on this flight, there were 6 customers. So they were not supported on this small part. They were not supported by public money to develop their first satellite. They had 6 customers ready to put a small payload and ready to pay them to have this payload flying. So very interesting example, and they will have next year, they just announced that next year they will fly again another payload, and they will continue to develop in this area. I think unfortunately, as is for emergency things, he's not here today, so we won't have the opportunity to speak with him, but of course happy to put you in contact with him. Out of these examples, 3 of them, especially ClearSpace, Pictera, and DeFi, were incorporated by the ESA BIC in Switzerland. So I wanted, and I asked my colleague at ETH to provide me with 3 slides about the program. So the ESA BIC Switzerland, well, you have also ESA BIC in Austria and in many countries in Europe now, in ESA now. But in Switzerland, it's a little bit special. It started in 2017. It is managed by ETH Zurich, but as you will see, it's not that we have a physical location for all the startups. Basically, you can stay where you want in Switzerland with your startup, but you can benefit from the program. And they have up to 10 startups per year supported over 2 years. It's a very competitive selection. They have 2 rounds during the year and a lot of startups or ideas, let's say, in the pipeline. And basically, you have for your eligibility to be less than 5 years old and registered in Switzerland. And probably the most important things different from other ESA BIC in Europe is that you can get up to 200,000 euro non-dilutive over the 2 years program. And it's come with, you have to show that you have a match funds of 300K also over the program. So it means that you have basically 500,000 of funding in total over 2 years. So very different and very important in this program because it's really triggered this idea of you need investment and you need to be very competitive to be in this program. You have a few examples of these startups there. And here you see from 2017, currently there are 22 incubators at different stages. Some of them are just selected, some of them will finish. And you see here all the alumni companies. And basically currently most of the companies are coming from Lausanne area and Zurich area. Not a big surprise because there are the two ETH or EPFL here and ETH Zurich, where you see really again that's probably coming from the associations, from all the attraction there are around these universities with the innovation parks and all what is going on in Zurich. So they're basically coming from there, but again there was also companies from the Ticino part, South part, Basel, Bern, so really from all around Switzerland in this program. And that's also the results to date with, again, 22 incubators with 65 alumni. Close to 800 million third-party funding raised by the companies incubated there. More than 1,290 jobs created in Switzerland in these companies. Revenue of close to 100 million, more than 30 startups with 1 million revenue after, per annum after. And you see here 3 exits and 15 million non-dilutive funding from ISA. So that was the 200K per startups over the program. So a very successful program that we have here in Switzerland. And that's also explaining why there is interest from founders to go in the space domain or to create this link or to find this link with space activities here. So in summary, on our side, the Swiss space formula, as we say it, a short and fast link between academia and industry. So the Swiss space ecosystem is very strong to turn research into innovation or commercial success. We are full bottom-up approach here. So basically, as a company, you can propose and go to the Swiss Space Office, explain that you want to do something in the space that seems to fit. We are there also to support as Space Exchange Switzerland to find the right position for you. And basically, so it will make sure that you're a reliable partner. We're not telling you what you have to do, but you can tell us where you're the best one. And of course, being part and a full member of the European Space Agency is very important. Again, we are part of all the mission, we are there in all the programs, and I can tell you from Switzerland, from Swiss perspective, not being part of EU, that's something which is really valuable in the space domain, and that's really helped us a lot in the past years. International, and that's the last point. I also put the flyer. So I wanted to let you know, I don't know how many of you knows about the International Astronautical Congress, IAC. And basically, so this year, last month it was in Sydney, and we were there to present our future candidacy for IAC 2029 in Geneva. So the selection will be done next year in Turkey. But we would be really happy to welcome all the world. So if you know the IAC, if your company is member, just that you're aware that next year it will be important because there will be the selection of the city. And we would be really happy to welcome you in Geneva in 29 again, maybe for follow-up of this 2 days meeting. So thank you very much. If you want more information, just go on our website, and of course I will be there the full day with you, so no problem to address your point. Thank you very much. And now I leave the floor to Emmanuelle David, who is Executive Director of the EPFL Space Center, and well, she will address more about sustainability in the space domain. So Emmanuelle, that's you.
Thank you. So while we wait, so I guess the sound is working fine also. Yeah, good. Thank you very much, everyone. So now I give you a lecture on space sustainability. It's an introduction. So at EPFL, we have a long-lasting heritage on space sustainability, and Grégoire mentioned the company ClearSpace, which is one of the spin-off from our space center. And the story came that we launched in 2009 the Swiss Cube. And shortly after the launch, there was a close encounter with another object. And that raised the question, okay, what do we do now with Swiss Cube? And we need to go and get it back. So unfortunately, Swiss Cube is still in space, but it's also good news because it's one of the long CubeSat that stayed the longer in space. But then it started some research around space sustainability, how to take space objects back to Earth also, and led to the creation of the company ClearSpace, who was awarded in 2019 this contract by the European Space Agency. But coming back now more like to our everyday life, you see here a very nice picture of the night sky. And I think most of you've seen in the night some satellite track, I guess. Who've seen also like a Starlink train? Maybe you raise your hand if you've seen this in the night. 1, 2, 3, yeah. You're lucky I've never seen it actually, even though if I look. But yeah, it's true that story is that, for example, our grandparents, they had blue sky, and there in their life, they saw planes going through the skies, coming, and we are the generation where we were kids, there were no satellite tracks in the sky, and now we see them. This raises a big question: is how do we protect our space environment, and what can we do for that? So for that, I will walk you through what is space sustainability, what are some of the impact of space activities on Earth and in space, and then we'll answer the question: what are the challenges and opportunities in terms of like policy, guidelines, regulations, how you can implement it technically, because we're also here with a more technical audience. But also opening the talk with like what are some possible futures for us and how we envision also the future use of outer space. So the space objects, space debris situation. Here I have two graphs from the ESA, so the European Space Agency Space Environment Report from 2025. And we can see here, does it work, the pointer? No, but it's fine. We can see here the increase of the launch traffic, and we see here, especially in the last 8 years, a very big increase of space objects. So you would guess who would be one of the main contributors of this yellow bar? Yeah, US, and it would be no, SpaceX, exactly. So it's a commercial. So we can see that most of those objects is from SpaceX, but we are definitely in an exponential growth, and there is no trend that will show that will decrease. Some of the simulation that... yeah, question?
What does amateur mean? Who is contributing to the black part?
So amateur would be, for example, I think us, a university, we are launching a CubeSat for students, and that I think would be considered as an amateur satellite. And then they perform also some simulations and looking at two scenarios. Here we do no further launch, and here we continue with the launch rate of 25. And we see what is the cumulative number of catastrophic collision. A catastrophic collision is really two objects colliding, and then there is you lose your mission. This is a catastrophic event, like in 2009 with the collision between Cosmos and Iridium. We see that even if we stop launching today, the curve still increase slightly. If we continue, this increase drastically. So it means the outcome of those scenarios, it means at the end you cannot use also outer space. We are not in a trend where we can continue to use space as it is. And in parallel, Starlink here, they plan to launch up to 9,000 kilometers until 9,000 satellites until 27, and they also have an approval for up of 30,000 objects, and their satellites, they are getting also bigger. There is OneWeb also who started to launch this year, a few years already ago, and Amazon Kuiper who started to launch this year. So if we continue business as usual, the orbit around Earth may become inaccessible within the next few decades. I think this is a fact, and we shall all agree on that and accept it. So now, in order to solve this problem statement, we need to understand what is space sustainability. Who here has an idea of what it means, space sustainability, for you? I guess not the first time you hear the topic, yes. And
Decommissioning satellite at the end of life.
decommissioning satellite.
Basically, there is a demisability as well on the re-entry.
Demisability on the re-entry. Maybe I repeat the answer so for the people online. So these are like some solutions. So how would you define space sustainability also? Other
It's extension as well with life. So
extension.
I can speak for
There are people
Okay,
online
so
also.
extension, service extension, like everything which is related to service in orbit. No, it's not. Is it working or not?
Is it working?
Maybe
Yeah.
not.
Okay. Yeah.
Ensuring the access to space is protected and accessible for future generations.
That's a very good point also. And that's very much in line with the definition that we have that was agreed by the Committee of the Peaceful Use of Outer Space that defines space sustainability as the ability to maintain the conduct of space activity indefinitely into the future. So it's ensured that we can use space and develop space-based infrastructure, but also needs to meet the need of the present generation while preserving the outer space environment for the future generation. So there is also this idea of being continuous, but also of equitable access for everyone and for all the actors. Where in Europe, we've been accessing space since decades, the US, but you also have a lot of other countries that are trying also and developing their own space capacities, and we need also to access this space. So there are some definitions that also look at space sustainability and define it through 3 pillars. So first is the sustainability from space, so using space as a platform to directly or indirectly address a global problem. So this is exactly when we talk about space for Earth observation satellites, but also using space assets for problem on Earth with global navigation system. So this is one aspect of space sustainability, and this one big benefit of what space can bring for Earth. The second aspect is really sustainability in space, and I think this is in the community what we talk a lot when we hear space sustainability, is viewing space as a natural resource for the preservation, exploitation and exploration. And that's why we want to mitigate risk, manage space debris, extend the mission, but also preserve the dark and quiet skies. So this is sustainability in space. And finally, there is a third pillar that sometimes we don't think too much about, is the sustainability for space is also to protect the terrestrial development from the impact of space activities. The space industry was not such a big industry, but now is booming, so it means the impact of space activities on Earth, such as any other industry, has an impact on your local environment, the sourcing of your materials, but also the impact on the atmosphere. So this is why there is a researchers that enhance the first definition that I mentioned, to really look at space sustainability with the aspect of on the ground and in orbit, to really ensure the continuing access to space and also to require the promotion of the use and the promoting the use and environmental benefit of the space data, and recognizing also the needs that we have. And from this definition, there is something that came, a concept of the space sustainability paradox, meaning that if you want to be fully sustainable in your mission, you cannot claim that you're saving lives because you check fire data or you provide space weather, while also putting at risk the space environment, or even polluting some aspect on Earth. So this is why you really need to have a holistic approach while addressing space sustainability. So what are the impact of space activities in this more holistic manner? So concretely, this starts on Earth where, during production of your space capacities, during transport, transport of goods, transport of persons also, That's important. So we see here the new Calypso ship that is transporting some elements of the Ariane rockets now to French Guiana. So this is one step also to be more sustainable. There is also some impact on the oceans. So here is a picture of an Ariane 5 booster, but I think you all have seen some pictures of the Starship test flights and all the impact around Boca Chica. So that also raises some questions. During launch or testing, you see here a lot of exhaust gas from a P120 test in French Guiana, but those are impact on the different layers of the atmosphere, and the more you launch, the more impact you will have. There are also the impact in space. So I showed earlier also a slide on the increase of space objects and also the risk, the collision risk. But so this is only one part of the picture. So collision, you have catastrophic event, but you can also have hypervelocity impact on your sonar panel or also your different elements of your spacecraft that can also put at risk your mission. So then could also lead to catastrophic event at the end. Then you have the impact during the re-entry. Burning an object, re-entering an object into on Earth and burning it is one of the solutions that is proposed to reduce the risk in space. But then burning a satellite and all the elements that you have in it also have impact on the upper layer of the atmosphere. And this is a big unknown in the community. There were some papers showing that there were still some particles of aluminum that were found on the upper layer of the atmosphere. So what does it bring? We're trying to solve climate change. Let's try not to add another layer to this. Then during those re-entry, you have objects that then can also reach ground, and then you could hurt someone. So this is a picture of a ISS battery that re-entered, I think it was 2 summers ago, and went through the roof of a house. So thanks God there was no one in this house at that time. But imagine if it goes on someone. So far, no one has been injured by a re-entering space object. I think the only casualty was a cow in Australia. But to showcase that, I think the day you have a space object that re-enter and hurts a human, that will also increase the awareness around it. And we see also sometimes in the newspaper, there is an object re-entering and we have to be careful. And finally, there are the impact on the dark and quiet skies. So dark skies is really something we see, and it's very tangible. Quiet sky is for the radio astronomers. So we have huge infrastructure to listen to the sky, and they listen to galaxies and events that happen very, very far away. So those are very quiet, very low noise, and the satellites are too noisy. So it's really blurring this. And those investments, there are billions of investment from different countries. And I want to mention, for example, the SKA, so the Square Kilometer Array, which is a huge radio astronomy project in which, of course, Switzerland is taking part of. But the size is really the size of the CERN. So you don't want also to put at risk some of this research that try to answer some of the big questions. Where do we come from? Where the galaxies, how they are formed, everything. Okay. Now that I make you a very depressive view of what is the space industry, don't worry, there are solutions. You have people working on it. So let's walk through those aspects. So I will first walk through some of the policies, guidelines, propose you some technical solutions, how to design more sustainable missions, and then I'm sure you will feel better and you will want to act also in those directions. So in terms of space policy and diplomacy, anyone knows what are some of the big treaties in space policy? From when, maybe when they were signed? No? Perfect that you're here, so I can teach you about it. So there are 2 big treaties. So a treaty is really where countries come and sign the paper together. So there is the Outer Space Treaty in 1967 and the Liability Treaty Convention in 1972, where the countries really sat together, decide to some of the big lines on how we should use space, really to put freedom of exploration, to explain also what are the state's responsibility, the fact that you need to register space objects. So I think if some of you've launched objects, you know you have to go through this process through your country, but also to avoid harmful contamination, for example, when you perform exploration. In the liability convention, there is also some definition of damage, launching state, and space objects, which means that if, for example, there is a collision between two objects, in terms of like responsibility, the states that own the objects is also liable for this. And the launching state can be the state that produce the space objects, that launch the space objects. So if I have a Swiss satellite which is launched from French Guiana, the launching states are Switzerland and France. But then in the space law area, there are still a lot of unknown because how to apply those treaties, because there was no events and no jurisprudence for that. So let's aim not to have a collision in space with another active object. Then, and those treaties is really what we call them hard law. So it's a treaty really flows down in your national jurisdiction. And in theory, then the country has to put them in their national law. Then, not so much happened. And in the last, let's say, 15 years, at the UN, so the COPUOS is the Committee of the Peaceful Use of Outer Space, there were some discussion around space debris, and they edited two documents, the Space Debris Mitigation Guidelines and the Long-Term Sustainability Guidelines. And there in those documents, they really put some solutions or some concept on for the long-term use of outer space, and that's where also you had this first definition. So a guideline is a soft law, so it means you don't have to apply it. However, those documents, they are discussed and they are agreed upon consensus. We love consensus in Switzerland. It means everyone needs to agree on the text and all the words. And this is why, for example, the long-term sustainability guidelines, it took over 10 years to get to this document. And states claim that because they discuss it and they agreed on about consensus, they will then apply it within their national framework. That's the hope. And then with this, you have countries that are developing their national space laws. One of the first in Europe is the LOS, the Loi des Opérations Spatiales in France, that was out in 2008. And why would France be the first one to have a space law? Why France? Because of Kourou, exactly. Because they do launch all the European satellites from French Guiana, so they really need to have this law. In the last years, we see in Europe more and more space laws. You have like 13, 14 countries that has a space law. Does Switzerland has a space law? This for the Austrian? Or the Swiss? Not yet.
They just started the consultation this year?
Exactly. So you can see that Switzerland signed a treaty in the 70s and is now having a space law. I think Austria has a space law. Well done. You do. Liechtenstein has a space law. So that's also very interesting to know. And then you have also other ways also where you have guidelines, you have ISO standard also. And recently also the Artemis Accords, which were an initiative from the US to get everyone on board on how to do moon exploration. It's a very US approach, but they got a lot of people on board. But you need to consider this is a diplomatic effort led by the US. It's not something that was decided at the UN. So most of those efforts and texts are non-binding. They are really open to interpretation. And today they do not impact. They do not cover impact on Earth. would be more the top-down, and because sometimes states talking together takes so long, you also have industry players that come together and discuss also and propose standards and guidelines. For example, you have the space industry debris mitigation recommendations from the World Economic Forum. You have satellite orbital safety best practices, where you have Iridium, OneWeb, and SpaceX that came together in 22. So those are also other industry initiatives. So that I would say this would be the space debris aspect. In parallel, we are in Europe, and in Europe, we also have a lot of regulations coming up around the environment and corporate social responsibility metrics. So there are two acronyms, ESG and CSR. So what is ESG? It's written here, yes, environmental, social, and governance. And CSR is the corporate social responsibility. So a CSR is really your company that defines sustainability objectives that can be really not only space specific, it can be also about the governments, avoiding money bribery, ensuring good work conditions for your employees. And ESG is really a tool in order to be able to measure and implement those objectives that you have. And in Europe, there have been in the last now 6 years, but there is a roadmap also to implement those principles for large company first, but then also it will go for SMEs in order also to reach the target to carbon neutrality by 2050. So there was first the Green Deal in 2019. In order to get to this goal, you need also to define different terms. So this is what we mean within the green taxonomy. So taxonomy is really the fact to define different terms and targets. Sustainable finance disclosure regulation, and especially the corporate sustainability reporting directive that really oblige companies to report some of their sustainability metrics. Of course, I think some of the goals in terms of dates have been postponed because there is always a back and forth between regulation and the industry that aims to be more competitive, and it's really expensive also to put all of this in place. And I think states and the European Commission and European Union should help those companies. But this is also very important to consider this, take this in mind, and this will come step by step. And then we get used to it, such as with the GDPR or the data protection, I would say, laws. Then there are also, in this whole context, some space-specific initiatives that are launched. And one side is from the European Space Agency that are really there to propose some solutions. So there is the Zero Debris Technical Booklet and the Space System Life Cycle Analysis Guidelines. So those are documents that are being updated. There is strong industry consultation on those. So if it's something you are interested, first you can download the documents, but you can also be part of working groups in order to understand this. And I'll talk a bit more about the Zero Debris Technical Booklet after. At the level of the European Commission, another nice acronym, the PFCR, which is a Product Environmental Footprint Category Rules. So it's an exercise to define categories, the rules for the different categories that would be in the space industry, so you can define what is your product environmental footprint. We understand that for space, you cannot do CO2 footprint. In space, there is no CO2. So you need to find other categories, other rules, in order to define this. And for that, they use the methodology of life cycle analysis, and so how you can apply it also for space and space-specific. Those category rules are really important because then they will define which are the data you need to provide when you do a life cycle analysis. And here in the room, we have mostly subsystems. So at some point, your prime, they will come, they will ask you data. So you need to be ready for that because if you know which type of data, when you do the development, it's more easy to get it than at the end. And then also you might have heard about the EU Space Act. Who has heard about the EU Space Act? 1, 2, I see a few people. So EU Space Act is really the EU's regulation for space, and does really address some aspect of space sustainability. There is space debris. Propose also the uses of life cycle analysis. You also have other aspects on cybersecurity also. There is currently a consultation also on that. You can provide comments, and I think it's until the 20th of November. So you can go, and if you want to criticize, you can. If you want to acknowledge and say it's great, you can. But I think it's a really good moment, because then there can be some exchanges also with the industry, and there is really an effort. But be aware that this is coming, and expected enforcement 2030. If it's not 2030, it's 2035, but it's coming, it's there. So it's really a timely topic. And despite effort, there are still a lot of misunderstandings. And I think my whole goal also at the end of this talk is to avoid any greenwashing talks. So we really don't like when people use green propellants, that thinks that just to be reusable is to be sustainable. It's one part, but you see it's not all the point. When we talk about clean technology, this is very... So be aware that if you use some of the terms, now you need also to be able to back up what you're saying on those thematics. So please, let's avoid greenwashing. Now let's go to the second part of my talk on some technical implementation. And this will be based on, we'll try to condense you some of the efforts that are done at the European Space Agency, especially with the Zero Debris Technical Booklet and some of the effort there. So the European Space Agency gives some recommendations in order for the zero debris approach. So this would be really the in-space part of space sustainability, so the pillar in the middle that I mentioned. So it's important that there is the definition of valuable orbits. And do you know which are the protected orbits today? There are 2. It's where most of the objects are. LEO and GEO. Well, easy. So there you have some specific rules. You need to deorbit. So the rule is 25 years. The recommendation is 5 years. So that's important. So we need to guarantee also a successful disposal. So I think this is important to improve the orbital clearance of those objects. So reduce the time left of the protected region below 5 years. Avoid in-orbit collision also. So you need to have a good collision avoidance strategy. Avoid cumulative probability of collisions. Avoid internal breakups. So this is about the reliability of your mission. So, and reliability goes up to the components. And this is also very important. And I think there's always a lot of discussion to do, especially if you're from the subsystem level, because system engineers, they give you like very constraining requirements on that. Prevent intentional release of space debris. So this is, I think, something which is pretty common. Improve on-ground casualty risk assessment. This is also important. And guarantee the dark and quiet skies. So now that you have the main principle, I think what is important is to think, okay, we do all of this, that will improve the cost. So there is always a trade also with the fuel lifetime and the additional cost. And if you want to be compatible with ADR, so active space debris removal services, and the new design features. And with people from my team, that we summarize some of the best hardware practices for sustainability in space. So we've done a very nice decision tree, and you can see what you can do. So does your mission has planned an in-orbit servicing mission at the end of life? For example, if you want to remove the object, yes, no. Let's say no. What is planned at the end of the life? You can plan an Earth re-entry. You stay in your same orbit as during the operation phase. You go to a graveyard orbit. You will just impact with a celestial orbit, let's say for you impact on the moon, on an asteroid, or you escape in a heliocentric orbit. If you stay in the same orbit, does the spacecraft cross the cross section? Does your spacecraft cross some crowded orbit? Are you in LEO? Are you in GEO? Yes or no? If you are in a crowded orbit, you do need to satisfy the current guidelines for direct re-entry or to escape this orbit. And you check, does in my simulation, do I get out of LEO within 5 years? Yes or no? And if you remove, so there is no need for specific additional hardware. And this is one actually of the strategy of SpaceX, because they lower their orbit for their spacecraft, so they know that within 5 years it will naturally decay, and so I'm also satisfying one of those guidelines. And this also, I think, why there is a strong interest also using the very low Earth orbit, because then within a few months you just get out of the orbit, so you don't need to have additional hardware. No. If not, then you might need to continue to have hardware for assisted in-orbit servicing, such as specific grippers or specific pointers. And in the technical booklet, you have some of those hardware that are presented. It's the same tree if you do Earth re-entry. And of course, if you if you don't cross crowded orbit, you might also want to have hardware for assisted in-orbit servicing. In-orbit servicing here encompasses the fact for active debris removal, but also for refueling. So that is also considered here as a servicing. Then graveyard orbit. If you go to a graveyard orbit, you might also want to have assisted in-orbit servicing devices. If you impact in a celestial body, check the interplanetary protection guidelines and regulations, heliocentric orbit, also hardware, and check the interplanetary guidelines. In-orbit servicing, I have planned to have in-orbit servicing. And in order to have an easier way to be serviced in the future, you might want to install markers for close proximity operations. So markers can be 2D or 3D markers, like a plaque with some black items, so that when the spacecraft come to service you, they can see exactly where you are, and it's easier also for them to do those proximity operations, and some mechanical interface also for the grabbing. What type of in-orbit servicing is planned? Do you want to have a life extension or active debris removal? So what type of life extension? It can be assisted GNC, so that can be also to help to detumble your spacecraft, refueling, and repairing. I didn't mention this one. So if you want to assist GNC, you do have also now devices to perform passive detumbling at the end of your life. Refueling, you have refueling interfaces, and the repairing, you need to make your component mechanically accessible. A very good example of in-space reparation was with the mission of Hubble telescope, where with the space shuttle, they went several times also to repair it, and we are very proud because one of the repairmen was Claude Nicollier, our Swiss astronaut. And I think so with this decision tree, you see you have a lot of like elements of what needs to be done, but also there you can see what is coming and which type of hardware you can also develop in the future, because there is a market there. Exactly. And then to finish this, I also want to open like with the motivation to measure. Because there are also some initiatives on like rating a spacecraft, or also in the EU Space Act, they talk about a space label. So it's important that in order to enforce space sustainability, or at least to showcase that we are doing better, you need to measure it. And this is a quote for Professor Mori Badja at the University of Texas at Austin. You can't enforce what you don't manage. You can't manage what you don't know. And you can't know what you don't measure. And this is why measuring is very important. let's say, it's the KPIs of space sustainability. And one of the initiatives here, I put the logo, is the Space Sustainability Rating, which is an initiative that was actually initiated at the World Economic Forum that gives a rating to the mission and assess the level of space sustainability. In that aspect is also important because it showcases that you have a third party that looks also at your sustainability criteria and how you're doing. So in that way, you avoid greenwashing because it's not just yourself saying I'm good, it's someone else also. And the EU Space Label in the EU Space Act might also show some of those aspects. I'll just drink a bit, and then we go to the last part of the presentation. I really like this picture. WALL-E, who've seen the movie WALL-E. There is a very nice scene where the robot wants to escape Earth, and then he has to go through all of these like crowded orbits. And I think this is really not a future we want to have. But in order to do this, to avoid this, we talked about technical solution, but we are part of a whole system, and there are also some socio-economic considerations. So one big notion that is important is the notion of problem shifting. You can solve the problem somewhere, but then you create one somewhere else. And this is why it's really important to have this holistic approach. So what are the problem shifting you can perform between Earth and space? I mentioned the atmospheric pollution. So we perform re-entry in order to reduce risk in space, but then we burn in the atmosphere, and then we might also create problem within our atmosphere and in the upper layer. This is problem shifting. So we need to have research on that aspect, and we need to give also money for researchers to look at those aspects. But there are also some shifts between the environmental, economic, and social dimension. So do we want to protect the environment by reducing the number of satellites? That could be also a solution. It's not everyone that needs to have its own satellite to have shared infrastructure. And here in Europe, we are champion on that because we do this with the European Space Agency. We are over 28 countries. 23, sorry, 28 is the EU, then 23 countries sharing space-based infrastructure. But on the other hand, we do want to promote industry growth, and how to promote industry growth, you need to build more satellites. So this is also an issue of problem shifting. But also, we might also endanger, we want to protect also local communities that value dark skies. Maybe not our communities in Europe, but we know about indigenous populations that value dark sky. You want also to protect some of some species, animals that need also dark skies. So it's a very big, I would say, system we are, and it's a very, I would say, it's a societal issue that needs to be considered. And we should not just take one or the other of the three aspects into consideration. So within a project we've done also with a social scientist for a paper that we published at the OECD Space Forum. So we looked at different scenarios also on how would be space governance in the future. And there were three different scenarios. So one is like the space government is led by individual governments. So really a bit what we see, that every country now is going back to themselves. It's not that we do so much of we try, everyone is more individual. Space governance is led by private actors. You have here a nice picture of Elon Musk. Are those companies leading what is going to happen in space? Or is space governance led by international organization or multilateral fora? And then in this study, we looked at what could be different impact, different scenarios, how it goes. Of course, at the end, the real scenario is a mixture of those three. But I think it's important also to ask ourselves, what do we want? Who should be deciding about our future and how we use space in the future? And then some of the political contestation that come with it is growth perpetuity or not. We have a society, an economy which is based on growth, but we're also delaying planetary limits for our economic expansion. I think it's a question we have to ask. Do we want to go towards this? Is space a spatial extension of terrestrial powers? There are strong geopolitics questions there. The ultra wealthy with space tourism are also using this militarization of, increased use of space for military application, I would say, because space has been military since the beginning, but also to question this. The technocracy versus the democracy, meaning that we do value technology. I think we see this with AI, we see this with space, but we should not forget that we try to be in democracy, so also give power to the citizens. And then the last big contestation is the Earth versus space sustainability. So do we want to save Earth at the expense of space, or shall we take a consideration a big system, a Earth space governance, in order to to see this in a holistic manner? And now I'll go. There are some references in the paper, and I'll conclude with this: really to ask ourselves, like, how do we want to act as a humanity? So that's my conclusion for my talk. So I walked you through the definition of space sustainability, some of the impact of space activities. So now you should be clear that there are really impact on Earth in space. The sustainability paradox, very important to have really the whole view for your mission of what is doing, how you're doing, and what happens also, and how you produce it. Some policy aspect, regulations. I gave you some hints on how to design more sustainable missions, and then I opened also in more socio-economic consideration that is perfect to discuss after around the coffee break. And I will use a last tiny second just also to make some self-advertisement. If you enjoyed this lecture, we do have a 3-day course on space sustainability, how to design a space mission that's taking place here in March at EPFL in this exact building. So don't hesitate also to come to me if you're interested also to learn more and to also learn about the tools, and you will hear also about other experts. So exactly. So thank you very much for your talk and bearing with me.
Thank you very much, Emmanuel. Thank you very much for this nice overview. Thank you, Gregory. I think this was a really good start for our event here this morning. Now we're really in the mood for this whole space topic, if you have not been it before already. A short, any questions? Please, microphone. Maybe, I don't know to whom it is. Please, yeah, go ahead.
Thanks a lot for this very interesting talk. Yeah, always very nice to see everything that you are doing here. I was wondering about what is being done in particular in the US, because you explained a lot what we do at European level with ESA, with Switzerland. You mentioned a little bit the Artemis Accords and what SpaceX is doing to passively deorbit their satellites. Are there more initiatives like the ESA space debris, the booklet, etc., a little bit similar in the US? Or is it kind of pushed under the...
So I would say what I see in the US is there are a lot of industry-led initiatives, and there was one of the paper I showed where you had like SpaceX, Iridium, and OneWeb that exchange, and this is through the Astronomic AIAA, so American Institute of Aerospace and Academia, something like this. But they are doing this. NASA also have their guidelines that they have to apply to NASA missions. In terms of regulations, I would say the FAA, so the Federal Aviation Administration, that gives license, and the FCC for communications, they also are pretty strong on that. Some of the SpaceX launch for Starship were delayed because of lack of information for environmental impact, also in Boca Chica, so they are trying. FCC has put also like this constraint of deorbiting after 5 years in one of the conditions to get one of the licensing. So I think in that they're also good players, and they understand also what is at stake. it might be less top down that as we are in Europe, maybe less coordination from NASA towards the industry. So I think that's a point. Something else with so SpaceX and Starlink. So sometimes I have mixed feelings about them because they send a lot of satellites and it's incredible and it's a lot. On the other hand, they know that they need to protect their own shell that they are using. So on that aspect, they are also some of the best players because their satellites are very smart. They do coordinate with OneWeb. They do play by the book. They do play the rules. You know, it's not that they don't follow, and they also push the rules on that aspect. And with their very large constellation, they showed that you can put much more satellites in an orbit shell that we would have imagined. So I would say they are also good players. And actually, if you would do rating, I think they would have also a very good rating because they share their data, their collision avoidance capacities, and everything. So that's yeah.
Thank you.
Thank you for this very balanced talk. You gave the idea of multipolar decisions by countries, companies, and then done by the United Nations. I suppose you want Elon Musk to rule it all. My question, but is, what about China, India, and Russia? Yeah, they are somewhat included. Do they play by the books? Are they good upcoming partners, or is it just a competition on another level?
Yeah, so that's a good question. I would say Russia, they do participate in the discussion at the UN level, so they are part of it. China also, I would say that from what I know, it's different. Like there was the anti-satellite test from China, and they did it in a very crowded orbit, whereas, for example, when the US and India did the anti-satellite test, they did it in lower orbit, so then the debris could come down. So I think there are definitely some communication challenge between US and China. Yeah, the anti-satellite test. So these are big nations showing that they can shoot a satellite with the missiles. They shooted one of their own assets because, of course, you cannot shoot another person, and that would be like terrific. Not terrific, terrible. But it's a showcase of power, and yeah, so far that were those three countries. And you mentioned India. I would say India. They try, they develop, and I would not say that they are so as strong as like with Russia, US, and China. But I would say what is playing in geopolitics on Earth is also there in space.
Okay. Thank you very much once more.
Thank you.
Thank you very much.
Thank you.
Good. We are running a little bit late. So first of all, I want to say thank you and goodbye to our viewers on the live stream. The rest of us, we will do a on-site visit here in EPFL and see what the students are doing and what projects are being worked on. So we're going to take a cup of coffee and move right on. Thank you.